In this video, let us look at a high level about a new LLM known as Eagle 7B. So this is supposed to be a better model when you compare it with transformer models which have been trained with 1 trillion tokens across 100 plus languages. So this model has a different architecture from your traditional transformer models. This architecture is known as RAW-COW, okay, RAW-COW or RWKV, okay, RAW-COW. So this is an RNN based architecture. And RAW-COW is an open source non-profit group under the Linux Foundation supported by their sponsors. It combines the best of RNN and transformer. So it has great performance, fast inference, fast training, and saves VRAM. And it has infinite context length and free sentence embedding, and it is 100% attention free. This is at a very high level. So this is the architecture paper, and what they are saying over here is that when compared to existing transformer models, this has lower resource usage when running and training. It has 10x to 100x lower compute requirements compared to transformers with large context sizes, scales to any context length linearly, whereas transformers scales quadratically, performs just as well in terms of answer quality and capability. These models are generally better trained in other languages than most existing open source models. The other languages are like Chinese, Japanese, etc. The bad things are it is sensitive to prompt formatting. You may need to change how you would prompt the model. Is weaker at tasks that requires look back. Okay. So you need to reorder your prompt accordingly. So instead of saying for the document above do X, it will require a look back for the document below do X instead. Okay. So this is the change in prompt. Okay. So if you go over here and look at what is this Eagle 7B in short, it's a 7.52 billion parameter model. It is built on this RAW-COW V5 architecture, which is a linear transformer with 10 to 100x plus lower inference cost. It is ranks as the world's greenest 7 billion model. They have a blog which explains why it is in terms of carbon footprint. Okay. Then it outperforms all 7 billion class models in multilingual benchmarks. It is trained on 1.1 trillion tokens across 100 plus languages. So it's a multilingual model. On English evals, it approaches Falcon, Llama 2, Mistral level of performance. It trades blows with MPT 7 billion, which is also trained on 1 trillion token. It is an attention-free transformer. It is a foundational model with very small instruct tune. Further fine-tuning is required for various use cases. They provide their own fine-tuning library with which you can do it. Okay, you can download this from Hugging Face and use it anywhere. There is already a demo available on Hugging Face. Maybe we can go and try it out. So here I said like this, right? A prompt is user, what is an SVM? Support vector machine, describe the core idea behind an SVM. And this is the text which is generated over here, which talks about what is an SVM. And it kind of explains it very well over here that the core concept is finding the optimal hyperplane that separates the different classes of data points in a high dimension space. The core idea behind SVM is to find the best boundary between different classes of data points and maximize the margin between them. So it explains quite well over here. I tried out some other text generation prompts over here, and it was quite good in my limited testing. So you can also try it out. The model is available on Hugging Face, right? And how to use it in Hugging Face is also available. Let me look at this particular. Yeah, so this is the Hugging Face port of this particular model. Okay, and here it is explained how you can run it on CPU via transformers. Okay, how you can run it on GPU as well via the Hugging Face transformers. So that code is available over here. You can go and already try out this particular model for text generation. Okay, and to learn more about what is this particular model RAW-COW, you can look at this particular wiki where they've explained about what is this particular architecture, and they have explained about this particular language model. Okay, so you can check that over here. They talk about how you can try it out. Basically, their demo where how you can try it out, Hugging Face demo. And it is more sensitive to the prompt, so maybe you can try like this. Okay. As the format, you should instead do the following. So kind of give an instruction context answer, not context instruction answer. That is the thing over here. So they talk about this over here. So you can try, read more about, what is this architecture. Let me see if some more details are present, because, I had looked at, okay, let's go back. No. Okay. So this is about the architecture. Yeah. Here they talk about, how is it different? Correct. This is what I wanted to talk about. So here they talk about how is this different from a transformer, and what are these concepts of a time mixing, channel mixing, and how with this making use of these concepts of channel and time mixing, they are able to, replace attention in a transformer model. So further details are present over here. And if you want to learn more about detail, Yannick Kilcher has a video about this paper. Okay, the original architecture paper. So you can study that as well. There are 2 other blogs which talk about, 150 lines of code for this implementation of this architecture. There are 2 blog posts which talk about that, and what is this channel mixing and what is this time mixing concept over here. This blog also talks about at a high level of, how this architecture overcomes, in transformers you have quadratic, when attention mechanism scales quadratically with length of sequence to be processed. Okay. And in RNN, what happens is that it is linear, but then when you have longer context, you have issues like vanishing gradients and other things. So how does this architecture combine best features of RNN transformers? Okay, so that is explained over here. At the high level, they say that it's a transformer type of formulation of the architecture during training, which allows massive parallelization with the sort of attention which scales linearly with the number of tokens. For inference, they use an equivalent formulation which works like an RNN with the state. So this combines the best of both worlds of RNN and transformers, and does much better than a transformer model in terms of long context length, and it uses substantially less memory, and it can implicitly handle infinite context length. But in practice, this model might have a hard time generalizing to much longer context lengths than it saw during training. Okay, so this is a high level view of this particular model, Eagle 7 billion. And here are the, how it performs across multilingual benchmarks and English bench performance details. I wouldn't go into the details of this. They're already working on V6 version of this architecture. So they're going to come up with newer language models in the future, right, which can scale linearly similarly to a transformer performance with a similar token count. It may not have succeeded in passing Llama 2 or Mistral, but it provides strong evidence that this architecture scales similarly to transformer performance with a similar token count. So if you do it on more data, probably the performance is going to improve. But inference cost is going to be low. That is what they are saying. And it supports multilingual levels of performance. So basically, it's a multilingual model. So they would come up with, this Eagle paper. They'll go into deeper in depth on the architectural changes, benchmarks, and other things. They would want to further train on a 1 trillion token. So this model will now be trained on 2 trillion tokens in the future. They want to come up with a mixture of experts model based on this architecture, and also come up with the next version of this architecture. So these are some approximate timelines, right? And their sponsors are Stability AI, Ulither AI, Linux Foundation AI, and Data Group. I'll be putting all these links. You can look at it. It's an interesting architecture. I would want to go in depth of this architecture to understand more about it. Currently, I just have a high level understanding of it. That's why I've not gone into details over here. Maybe in the future, I'll make a video on this. Or maybe Yannick Kilcher's video explains these things better. So probably I need not make a new video on this particular topic, so you can look at this video as well. I had a look at this video once, some long time back. So probably I need to look at it again for a refresh. So I'll be putting all the links in the description of the video. You can check it out. I hope this video is useful to you. If you like the video, please like, share, subscribe to the channel. See you in another video.